Welcome to lesson 10.4. And here we're going to be talking about perimeters and areas of similar figures. To start out with, we have theorem 10.7, perimeters and areas of similar figures. We talk about the scale factor of two similar figures. If we have a scale factor a over b, that's this right here, then first of all we know that the ratio of their perimeters is also a over b, and the ratio of their areas is a squared over b squared. So how we're going to use this theorem, we've got our first problem, we've got two rectangles that are similar, and the ratio of the lengths of the corresponding sides are 6 over 8, because we got a side of 6 right here that corresponds to this side of 8. 6 over 8, we can simplify that down to 3/4. So that is the ratio of the sides. So if we want the ratio of the perimeters from smaller to larger, we would use that same ratio, 3/4. The ratio of smaller to larger of the areas, so now we take that ratio we had before, 3/4, and now we square it. So we square the top number, we square the bottom number. 3 squared is 9, 4 squared is 16. My ratio of my areas should be 9 over 16. This next example, I want you to pause the video and work through it on your own, and then when you're done, go ahead and play to see how you did. One thing to keep in mind here, they change it up a little bit. They switch the two. They want the ratio larger to smaller. So make sure that you keep that in mind as you're going through here. Okay, so as you can see here, we've got the ratio for the perimeters is going to be 7 over 5, because we're going from the larger number 7 over the smaller number 5. To get the ratio of the areas, again, we have that 7 over 5, and we're going to square both the 7 and the 5. So 7 squared is 49, 5 squared is 25. The ratio of our areas is going to be 49 over 25. Now we're going to be using these ratios of similar figures to find the area of a given shape. So this first example, we've got the area of a smaller regular hexagon is 127.3 feet. So this number right here is for the smaller hexagon. They want to know what is the best approximation for the area of the larger regular hexagon. So we're going to use that area ratio. So we've got these two corresponding sides here. I've got a 7 and a 10. So to find the ratio of the area, I go 7 over 10 squared. So I need to square both the 7 and the 10, giving me my ratio of 49 over 100. Now, the area that I was given was with the smaller hexagon, so it's going to go with the where the 7 is in the ratio, or the 49. So I'm going to put 127.3 on top over x. X is going to be my area of the larger hexagon. So when I've got two fractions equal to each other, I can cross multiply. That gives me 49x is equal to 12730, so 12,730. To solve for x, divide both sides by 49.
By 49.
And I should get my answer of 259.8 square feet. Our next example has the scale factor of two similar parallelograms is 3/4. So I've got my scale factor of 3/4. So I'm going to write that down here. The area of the larger parallelograms is 96 square inches. They want to know what the area of the smaller parallelogram is. We are looking at area. So in order to find our area, we need to have the ratio for area. So I'm going to take this 3/4 here, and I'm going to square it. 3 squared is 9, 4 squared is 16. This is the ratio that I'm going to be using. I got the smaller parallelogram on top, the larger number on the bottom. So when I go to find my equation, my fraction that I'm going to set equal to it, I'm told that the larger parallelogram is 96. So 96 should go on the bottom where the larger number in my ratio is. And then I'm going to put an x on the top. So what I'm going to do is I'm going to cross multiply, and I should get 16x is equal to 864. divide both sides by 16, and I should get that x is 54 square inches for the area of the smaller parallelogram. Our next example, we've got the scale factor of the dimensions of two smaller pieces of window glass is 3 to 5. So this ratio right here is a perimeter ratio. The smaller piece costs $2.50. Now when we're talking about cost of a piece of glass, that is an area ratio type problem. So when we're asked to find how much the larger piece should cost, I need to take that perimeter ratio and square it to find my area ratio. So 3 squared is 9, 5 squared is 25. My ratio should be 9 over 25. Now the fraction that is going to be set equal to it, I'm given that the smaller piece is 250. So the smaller piece will go with the smaller number, and x will go with the larger number. Now when we cross multiply to solve, I get that 9x is equal to 62.5. Divide both sides by 9. I get that the larger piece should cost about $6.94. Part B. It will cost Maria $150 to have carpet installed in a room that measures 12 feet by 10 feet. At this rate, how much would it cost her to have a carpet installed in a similarly shaped family room with a larger dimension of 18 feet? So we've got a 12 by 10. So if I draw a 12 by 10 here, this is $150. So now they want to do an 18 dimension, but we don't know what this is going to be. Okay, so you'll notice that 12 and 18 are matched up together. That's going to be what we use for our ratio. 12 over 18, that simplifies down to 2/3. Now again, we're talking cost, and just like with the cost of glass, cost is an area ratio. So to find our area ratio, I square the 2/3, giving me 4/9. Okay, so 4/9 is my area ratio. My cost was $150, and that was for a smaller room, so 150 is going to go with the smaller number in the ratio. X is going to go with the larger. I cross multiply, giving me 4x is equal to 150 times 9, which gives me 1350. Divide both sides by 4 to solve for x. The cost of that larger room to get carpet installed would be about $337.50. Our last pair of examples here, we start out with two rectangles that are similar. The area of the smaller rectangle is 10 square feet, so I can put that this is 10 square feet. I don't know what the dimensions are, but I know that the area is 10. What is the value of x? So what I need to do is I need to also find the area of the larger one, and they give me the two side lengths, 8 and 20. So I can multiply those two together and get my area of 160 square feet. So I can actually use that as part of my ratio, 10 over 160. And I'm going to set that equal to my area ratio that I'm going to be trying to find. Now you'll notice 8 and x are in the same spots in both rectangles. So x will go with the smaller area of 10, 8 will go with the larger area. I do need to square them. So x squared is x squared, 8 squared is 64. So my ratio is going to be 10 over 160 is equal to x squared over 64. Cross multiply, I'm going to get 160x squared is equal to 640. Divide both sides by 160. I'm going to get that x squared is equal to 4. Square root both sides, the square root of 4 gives me 2. X is going to be equal to 2. Our final example of the lesson, we've got two similar parallelograms have areas of 81 meters squared and 121 square meters. The height of the larger parallelogram is 10 meters. What is the height of the smaller one? So we are given two areas. Okay, we are given 81 and 121. That's an area ratio. And an area ratio needs to be squared, so I need to figure out what's going to go inside of here when we're talking about heights. Now we're told that the larger one has a height of 10, so with the larger number in the first fraction, I'm going to put a 10, so a 10 is going to go on the bottom. And on the top is going to be an x. So I need to square this fraction. So I'm going to have x squared over 100. So my ratio is going to be 81 over 121 is equal to x squared over 100. Cross multiply will give me 121x squared is equal to 8100. Divide both sides by 121. I'm going to get that x squared is equal to about 67, because I get about 66.9. We'll round that up to 67 for now. Square root both sides. And I'm going to get, again, I'm going to round here. I get 8.18181818, repeating forever and ever and ever. So I'm going to round that to 8.2 meters. That's going to be the height of my smaller parallelogram.